Alright, thank you Richard for reminding. Now I have started. So we have missed a couple of minutes. Okay, so here we can see the, yeah. So under Hadoop 17, the output has been created and it is in this particular file. You can see that it is very clean data now. As you go to next block, and this data, if you look at it, it is ordered by the word, not by the frequency. All right, it is ordered by the word. You can see 161, 162, and so on. Okay, this is the word. If you go to the last block, you will see wrong, wrote. So you can see that. So this word called wrote has occurred 149 times and so on. Do you see that? All right. So for Michael Brown, it says that the data is not found. Are you sure you are providing this particular input folder? Please note that if the output folder already exists, when you try to run something, then make sure that the output folder exists. Output folder does not exist. Delete the output folder before you start doing anything. Okay. Otherwise, you will not be able to run the job. Correct. So this particular folder is not existing. Okay. So please look at the absolute directory. We are using this particular directory. Use this one. All right. Or you can have a look at my command. If you log in here, you can see my command. So let me send it to all of you. Okay. So that's my command. All right. Does it make sense to you? So we were able to clean the data as well as we were able to execute our own script as mapper. In the similar fashion, we could also use the in the similar fashion we could also use the reducer in if we have our own script for the reducer. All right. Now the other important aspect other than minus file option is for distributed cache. Okay, meaning this my cmd.sh, since it does not exist on every machine, so it has to be installed on every machine, right? So either you make this mycmd.sh a general program, it should be under user bin and blah blah blah. It should be basically, if mycmd.sh is available on every machine, then you don't require this last option, right? But your custom program, you cannot afford to install manually. Secondly, you cannot afford to uninstall. So this was a major problem. So whenever you have multiple files that you require in the execution. Or look at it this way. If my cmd.sh was depending on other binaries, you could also include those and they will be copied into the same folder from where my cmd.sh would be run. Okay, so a temporary folder is created in which my cmd.sh would be copied on each of the node manager, or you can say that each of the application master. All right. Now the other part is you can express that we want to have more than one reducers. Okay, we could say, all right, we could say it has got disconnected again. Hadoop 17 and again login. All right, and if we have this here, if you have to execute the same command again, we can execute it like this. Okay, with multiple reducers. If you want to say that we have multiple reducer, then uh, we can simply say number of reduced tasks should be 2. Okay, so now let the job URL come up, and then we'll have, okay, it says that the output directory already exists. Okay, so now we can just put one more here. All right, and let me just copy this as well. All right, I'll answer your question after this. Okay, it says that it is not yet assigned. Okay, so yeah. All right. So it is still starting the job. Right. If there are multiple jobs running parallelly, so only one person will be able to run a job, specifically if there is a single queue. Right now we have created only a single queue. Okay, submitted is this one and accepted. All right, it's doing something. Okay, actually somebody else's job is running right now. Never mind. All right, so all right, let it do something. All right, so there is a question for, can the mapper be some Java file too? Of course, it can be Java file. I'll show you that. And Sandeep Mane's question is, what is hash bin bash? Can anybody explain this part? His question is that when we were writing our script, we wrote first line as hash bin bash. This one. Okay. So we were writing that. Anybody? So every program in Unix or every script in Unix defines in the first line that how should this program be executed. So instead of the way in Windows, when you double click .py file or .some file, the the decision that with which program should a particular file be opened is done using the file extension. But in case of Unix, that decision is based on the first line of the file. So first line basically contains the name of the program along with the location as where is the program existing. And based on that, the program that particular program is what is used for executing a script. So here it says /bin/bash. Bash is a program which runs the shell commands, and therefore our sed command and this full script will be executed using /bin/bash. If you want to run it directly without, so here we are trying to run it directly, right? We are not saying shell my command.sh. Okay, we are running it directly. So if you have to run something like this, first you need to chmod it. You need to change its mode to execution. You have to do chmod +x. And then second is you have to define the first line like this. Correct. Thank you, Lloyd. Okay, so had it been a Python script, you could have written something like user bin Python. Had it been Perl, we could have written like this. And in case our program is written, a Perl is installed in say user, let's say in opt user bin Perl. If our program is existing here, Perl is installed in this folder, then that folder will be used. Okay, if we are using all right, that's pretty much about it. Now the number of tasks here, we can define number of reduced tasks to execute. All right. Let's see what happens. Yeah, it has been done. The URL for tracking was this one. All right. Now we can go to okay. Now you can see that we said number of reducer as 2, correct? When you see my command line here, we have written in this command line -d mapret reduce task as 2, correct? And this reduce task is what decides how many reducers are going to run. And if there are 10 reducers, there will be 10 output files. Right now there is one reducer. Therefore there is right now there are two reducers. Therefore there are two parts, part 0, 0, 0 and parts 1. Correct? Now your next question would be that which data goes in part 0 and which data goes in part 1. Let me explain to you that. So you can open this. Let me just open the second tab with part 1. So let's compare the data, which keys have gone, which words have gone into which file. This is 0th file, the first file, and this is the second file. Okay, so you can see that 00 has come to the 00 is in the second file, while 005 is in first file. Okay, first file, first file, second file, first file, second file. You can see that. So two words, these are words, okay? They look like line numbers, but they're actually words. words from that file. That file contains these many numbers as well. So no two words have gone to so one word hasn't gone to the two files. Okay, so one word has only gone to one file. Okay, second is the if we concatenate part 00 and part 01, we will not get a sorted order. Why? Because you can see that 005 went to the first file and 00 went to the second file and so on, right? So basically, the first file and second file, they are individually sorted. The data you can see that 005, 01, 025, this is individually sorted. Okay. Similarly, the second file is also individually sorted. But if you concatenate them, it will not form a ordered one. You will have to sort them again. Okay. Now the question would arise that how do we make sure that the first file and second file has non-overlapping ranges of data. Right now the data is heavily overlapping, the range is overlapping. Okay, so that we can control using combiner, which we will discuss later. Are you with me? All right. And the input data, what we have done just now is, again, we we have taken the input file from this location, all the files in this folder, and done a word count by first converting the lines into one word per line, then giving it to Hadoop after sort, and Hadoop sorted it. And after sorting, Hadoop has executed our reducer, which is essentially doing unique minus C. Okay, and unique minus C just finds the unique words in the sorted data. Now, the interesting twist happened when we said execute our reducer on two different nodes parallelly. So some words went to first reducer, some words went to the second reducer, but there was no one word did not go to two reducers. It went only to one reducer. Second, the ranges were overlapping, as in if we concatenate first and second file, we will not get the ordered data, while each individual file is ordered. Okay, you can see if you go to the last block, the you can see womanish has gone to the second file, while women while has gone into the first file. Okay. Does it make sense what I just said? Yeah. Now Richard's question is, why do we want two reducers? Okay. So sometimes when our reducer is overloaded, okay, when our reducer, one machine is doing all the heavy lifting or of counting the unique letter words. Now, if reducer get overloaded, then you have to have multiple reducers to do our job. Okay. And the statistics, as in how much time has been taken by reducer and how much time is being taken by the mapper, is available here. Okay. So total time spent by all mappers is this much and reduced task is this much. Okay. So based on these numbers, you can clearly see that okay, our reducers are taking too much time. Why don't we start with having more reducers? Okay, and this is how you generally address the problem of having. Okay, so all right, so this is how you generally reach to a conclusion that okay, our reducers are heavily loaded. All right, so we have done a hands-on. Okay. For more details on streaming, if you want to do various kinds of magic, for example, right now our mapper program is expected to give out only key and key tab value, right? In case you want to use any other characteristic, any other character or any other special string as for separating out key and value instead of tab, you can configure it. Okay, you can configure it, and those things are available in detail on this documentation. All right, sometimes you want to have that a composite key. In case of streaming, you can define the composite key like this. Okay, so all those detailing is available in the streaming job documentation. Okay, so you can also define the what is the map output key field specification, that the map output should be considered as from here to here. And so basically you can finally control as in which fields need to be considered for sorting and all. So Lakshman's question is, it's a good question and tough to answer. So yeah, Lakshman's question is, why can't Hadoop programmatically decide number of reducers? Because Hadoop cannot predict Hadoop cannot predict the information about what is there in your reducer. In case your reducer is complex, your code is complex and is doing so much of heavy lifting, then you will have to use more number of reducers. Okay, so Hadoop cannot predict what is there inside your logic, and therefore Hadoop cannot automatically decide about number of reducers. Okay, you use number of reducers when your reducer code is doing too much of heavy lifting, it's taking too much time for you. Therefore, in those cases, you increase number of reducers. Okay, the only thing Hadoop could do is that if you run a job again and it figured out that it's the same code being run, then it knows that how much time it's taking. Based on that, Hadoop does some things in scheduling. Hadoop tries to predict that, okay, this job takes this much time, so let's schedule it in this manner. Okay, but number of reducers is a very difficult thing to judge, and there are high chances that it will go wrong always. In case if we have to use more number of reducers, how to bring the required output to a single file? That's a question from Shravana. So one is that why do you want to bring it to a single file? Okay, if you really want the data to be ordered in certain manner, then you can use a good, what do you call, partitioner. Okay, I will show you how to create a partitioner so that the data in one file and data in another file generated by reducers is mutually exclusive, such that you can simply concatenate them and the data you get is simply a single file. You can simply concatenate them, all right? Or in case you do not want to consume this file and the consumer for these files is another MapReduce task, then you can tell the MapReduce task that the input is a folder, not a single file. Make sense to you? So the worst, this is a question from Anuj. There is a So the worst case in case of multi-reducer would be if we have less unique keys than the number of reducers. That's correct. If you have only if you have only 10 unique words in the file, okay? And this is a very good point which Anuj has raised. So if you have, let's say, 10 unique words and 20 reducers, okay, now there are 10 unique words only in your whole file and you have defined 20 reducers. So basically it will only execute 10 reducers and with these 10 different unique words. Okay, so I'll tell you a very interesting case what happened. So one of the students just took a single line, this is a word, okay, and concatenated it around a million times. Okay, so it became like is a word, this is a word, like this, and it was around a million times. Now the magic starts. He feeds this to the word count problem. Now, since this is a single file, it's a single line. It's in the single line. So there is a single mapper, one mapper. So one mapper was fed to the whole with the whole data. So first mapper got the memory overflow. Okay. All right. So he increased the mapper's memory to say 1 GB. Okay. Now mapper was running fine because there was single map method which was being called for the whole file. Okay, not the single node, single map method was given this full line, right? So map task was getting the overflow. Now next problem occurred that for this there were million values, for is 1 million values, for a 1 million values. So basically there were four, at most you could have four reduce tasks. Okay, so basically word 1 million values. Okay, now all the reduced tasks went for an overflow. So although this is an innocent looking file, but in effect it's actually very difficult to solve it using the traditional techniques. Are you getting my point? So Shravana is saying that map depends upon the block size, and how come there is only a one mapper? The reason was, as per the logic which has been provided to us using the reader, which we will again discuss in a minute. So block, even though there are multiple blocks, the Hadoop created a single map, a single line out of all the blocks. Okay, because we want to interpret a single line at a time. Okay, you will understand this part as we go forward, because on top of block, on top of the raw data which is stored in the block, the records are being created. Although there are multiple blocks, but there is a single record being created because it's a single line. Yes, that's correct, Lakshman. So Lakshman's question is, so in this case, the mapper record is a data in complete file. Yes. And in those cases, how can we reduce the record size? Give me suggestions. I have a couple of ideas, but yeah, give me suggestions. So Ravikant is saying by splitting the file, even if you split the file and let's say you combine the file, and I mean, still it'll be a problem. All right. So Ravikant's question is partially correct by splitting the file. Okay, good, good. So Lakshman's question is by defining a custom record. Yes, that is the thing which we would like to discuss now. Okay, we could define a custom record such that we could say that our record is a fixed width. All right, our record is a fixed width. Instead of having record being separated by new lines, we'll say that our record is fixed width, and we can solve it that way. All right. Good. We'll talk about how to define or customize the records. Good. All right. Now, next thing which I want to discuss are there are a few different circumstances. So first, it's okay not to have any reducer. There are situations where you only want to do mapper kind of work. There is no need of having a reducer. Okay. In those cases, you can explicitly tell Hadoop that, hey, I don't have any reducer. Please turn off the sorting. So you can also say there is no reduce task and mention it to Hadoop that there are no reduce tasks. So please turn off the sorting. In this case, the data from mappers will directly go to HDFS because there are no reducer. So based on how many map tasks you have, based on that, the number of files will be created. Okay. So number of mappers will decide how many files are there. Number of mappers is a function of function of basically the number of blocks we have, or number of records we have. Okay, we will use a proper word called input split. We will talk about input split, which is very similar to what is a block, but a logical representation of a block. Okay, so number of maps is a function of input split, which is a logical representation of a block. And you can also force Hadoop, also force Hadoop to have custom number of map tasks. Okay. In some cases, what happens is that even though your block size is small, okay, you want more number of mappers parallelly. Even though your input file is very small, still you want more number of mappers. Okay. In those cases, if you want more number of map tasks to be executed, you can force Hadoop to execute them parallelly. Okay. What could be these such circumstances? Let's say, let's say artificially we are trying to compute some CPU intensive work. Let's say we are trying uh, uh, to do some DNA sequencing, in which we have to try millions of permutations in order to check against some value. Okay, let's say we are trying to crack the passwords. Okay, let's say we are trying to crack the password. So what we have to do is we have to use more and more machines parallelly. One machine cracking all the permutations of all the passwords which are starting with A, second machine starting with B, and so on. Let's say we are trying to do that. Okay. In those cases, even though our input data would be very small, we could force Hadoop to use more mapper. Okay. Good. There are a good amount of questions now. Sharna's question is that will there be a chance to break a word? Yes, it can be. And okay, yes, go ahead, Sravna. You have not completed. Okay, I got your point. So will there be a chance to break a word in that case? Yes, of course. Because if you have fixed width, then there could be the word is broken. Word could be broken in the way. All right. If we have record of fixed width, you will understand this. No, no worries. You will understand this. We will talk about it just in maybe in the second half today. Okay. And it's good to have that curiosity because that's what will make you understand how exactly Hadoop is converting the raw blocks into records. Okay, let me ignore this question. He has realized it. Okay. All right. This question should be ignored. Okay. All right. Now, there are some times we need to decide upon more number of reducers, specifically when there is too much of work being done by the reducers. Okay. Honestly, if you ask me, mostly is number of reduced tasks is a guesswork. All right. So, and if you can see this, it's also again a guesswork here. So number of reduced tasks which you need to specify should be somewhere between zero point 0.9 to 1.75 times the maximum possible task in your cluster. How many maximum possible tasks are there is basically sum up all the maximum tasks on the whole cluster. If one machine, one node has two processors, and you want to execute two threads parallelly on that machine, so there are four tasks possible on that machine, right? And you sum up all maximum tasks possible in your whole cluster, and you will get the max possible task in on your Hadoop cluster. So basically, basically find out the capacity of your cluster, that is in terms of number of tasks that can be executed parallelly on your cluster. Okay, so and then multiply it by a factor of 0.95 or 1.75 or somewhere between. Somewhere between is a very big range. Okay, so the general recommended one is you start with the number of maximum tasks possible on your cluster and then keep on increasing or decreasing it. All right, and it's mostly a hit and trial. It's mostly hit and trial. So here are a few things. If you have more number of reducers in your cluster, it will result in a faster, it will be little faster, more framework load because there will be more shuffling. As we have talked earlier, if you increase number of reducers, there is more network traffic, but there will be lesser chance of failure. Why? Because the load has been divided amongst multiple machines. If one machine is failing, only a small section of data is failing, and that can be quickly rescheduled to somebody else, right? Therefore, reducers are also resilient in nature, in the sense that in case one reducer fails, the work get transferred to another machine and the other machine starts working on the same data. Okay, now there's a question from Lux. The question is max task a variable for a given MR task or all MR tasks that can happen in the cluster? Max task is something you collect as a number. If you have a dual core computer, okay, dual core CPU, you would generally like to have maybe 4 tasks in parallel. And if you have 4 core processor, you would like to have maybe 8 tasks in parallel, thinking about 2 tasks in parallel on per CPU, and therefore the total max task possible on your cluster is 12. Okay, 8 plus 4. Make sense to you? So basically, you want to execute, you want to say that my cluster can execute 12 things parallelly. And based on this, you decide number of reduces as well. Great. So we have discussed all of this. Moving ahead. Now, there are a few things I want to make you aware before we jump into Java part. First, every toolkit or every framework has its limitations. All right? And you should understand the use cases about when to use what. Okay? It should never be like if you have a hammer, you should think everything as a nail, right? You should not think everything as a nail if you have only the hammer, right? You should basically understand when to use what. And most of the people, when I look at them and look at their work, what kind of work they're trying to get done over MapReduce, I find that that can be actually done better without the MapReduce. Okay, so if your work is finishing in a reasonable time, and in future you do not see the data growing drastically, okay, then get it done only on one machine. Don't try to use MapReduce for the heck of using it. You can do it for learning purpose, or in case your production data is bigger than the training place, then it's okay. But even if you see your production data is not going to grow bigger than few GBs, and we can do it better on the single machine. even after 5 years, then there is no point in using MapReduce. Okay, so next situation where you should not be using MapReduce is when your map tasks depends upon the previously computed value. As I was telling you, every map task will get a record and nothing else. So every map task is independently operating upon the data without acting upon previously computed value by other map tasks. In those cases, you can clearly see that if your logic depends upon previously computed value, for example, Fibonacci series. What is Fibonacci series? Fibonacci series says that the nth value in this series will be summation of previous two values. Okay? A value in this series called Fibonacci is equal to the summation of the previous two values, and same keeps on following further, right? So you can clearly see that in case of the Fibonacci series, you need previous two values. And in map task, in MapReduce, you do not have access to what other map tasks are doing. In case you try to do the coordination by the use of third-party databases, it is going to be humongously expensive and inefficient. You can get it done, those kind of things done without MapReduce very well. Second is, MapReduce by the nature is a batch process. In case you need real-time response, do not expect that from MapReduce. Okay? The strategy, the design has been with respect to get it done somehow even if it takes more time. That is the whole psychology behind MapReduce tasks. And in case your algorithm humongously depends a lot on a central state, then do not use MapReduce, because imagine if each of the map tasks is calling a central database or calling a central queue continuously to get the data, then it is going to be very slow. Okay, so these are the situation in which you should not be using MapReduce tasks. So Shravana's question is, can we use Spark for real-time response? Sort of, yes. Sanjay says that, what about recursion algorithms? Okay, very good point. Thank you, Sanjay. Now, for recursion algorithms, it's very difficult to, you will have to convert the problem into kind of a sorting problem. Okay, you will have to convert your algorithm into sorting problem. Okay, so only then you will be able to create an effective MapReduce. So some of the recursion algorithms can be converted into sorting problem. Some of them cannot be created. All right. Okay. So a few notes about testing. So when you are testing your MapReduce job, always first test on very small data. And this small data, once you are done with your first run and it's running fine, the next run should be randomly picked small data. Okay. Now, once you have done that, next point you have to keep in mind that you should be always separately testing mapper and reducer, and then combining them and then testing. So for every test, you have to have three test cases. one for mapper, one for reducer, and one for map reduce job. If you are using streaming job, it's pretty straightforward to do that by using sort command. Okay, and also note that the sort commands sorting basis you have to understand. Okay, because you might be sorting your key values on based on certain parameter, you have to do the same thing in case of sort. So in case you have input file, you have a mapper, you have a reducer. You can create a pipeline and then test whether it's working or not locally without Hadoop. In case if you are trying to code in Java, your MapReduce, we will talk about it now. In those cases, you can use MR unit. And if you want to test the predictions, split the predictions into two parts chronologically, and then generate the prediction set and compare the prediction against the actual. Okay, so probably this is something to use in case you are trying to test a prediction. Let's say your MapReduce task is doing some kind of recommendation that you will like to buy this kind of thing, or this user would like to buy this kind of product. Now, to test such kind of predictions is a tough thing. You basically test on the historical data. You test on the historical data against you test your recommendation against the history, and then saying it confidently that because my results were very close to the reality in the past, that means my recommendation is good. All right, these are a few notes about MapReduce. Now here is an assignment for you. Okay, so here is an assignment for you. Whatever we had done, whatever we had discussed, code it in your favorite language, create a project on GitHub with your code, and mention no big data in the readme.md. Okay? And share the repository with me. I'll have a quick look and review the code. Okay? So basically, this would do a couple of things for you. First, it'll give you the visibility. It'll give your profile a bit of visibility that you are working in with no big data. Second, it will help you understand the new genre of version control if you're not aware about Git and all. Okay, so basically, try to create a Git. Okay, create a project for your GitHub. Okay, create a project on GitHub for your code. All right, and then share that with me. Next problem to all of you is, based on the content from very large text archive, formulate the next word recommendation. We call it n-tuple problem. So I have seen lots of people doing this using R and other languages, but in R, it will overflow the memory. And in case the data is in few 100 GB, then R cannot be used to formulate this kind of problem. So in this case, we will use MapReduce to solve it. Okay, so there is a huge text, and based on that huge text, you have to suggest that after a particular word, what is the word people generally type? Okay, after a particular word, what is the word which people generally type? All right. So in this question, is this question clear to everyone? So for example, you will realize after reading a lot of text that when people type happy, the next word that generally comes after happy is birthday. And then the next one is new year, and the next one is marriage. Okay, so you have to form this kind of recommendation, and how would you do it? Okay, is the question clear to everyone? No? Yes, these are the assignments are available in LMS, and okay, so is the question clear to everyone? No? So you must have seen when you are typing a word using let's say Android phone, when you are writing a message or something, Android phone keeps on giving you the recommendations. If you type Sandeep, there are high chances that you will get Giri as the recommendation, right? Is the question clear to everyone? Shravana, Sanjay, Michael, Anuj, Ravikant, everyone? Jairam, Joshi, Kanaga, Karthik. All right, just go through this question and think about it. And there is one more question which I would like to answer before taking a break. The question is, what is GitHub? GitHub is basically a public open source repository of various source code, and it's a social way of programming. As in, when you write code, you are judged based on how many people have fork your repository and how many people have favorited your repository. Okay, so the number of more and more followers are there for a repository, which means that repository is very popular. It will be great if you all the 4 or 5 problems, if you push it to the GitHub. There it will be visible to you even after this course, even after some time. The code will be visible in public, and you can keep on improving it, and the all data and the whole log will be maintained. Okay, it'll be quite helpful to you. Although there are chances that my other students would like to copy it from, but that's okay. That's okay, because most of the students are mature and understanding, so they know that they have come to learn, and therefore almost everybody tries to do it by themselves. Okay, so basically instead of submitting the code, so Vidya's question is, she did not understand the GitHub's part. Yeah, if you remember, the problem you have faced recently when you submitted the code is the formatting is gone for a toss. Second, you have people have submitted the same code multiple times after making the improvement. So basically, we are not able to do it effectively using any of the tools. So either we launch our own source code system, or you could use a publicly available repository of GitHub. So you go there, register yourself, create your project, and start uploading your code over there. This way, you will learn a new source code control tool called Git, which is probably the universal source control tool as of today. Even at Amazon, we had migrated to Git, for our version control. And even at No Big Data, we use it quite extensively. Okay, so it's a great thing to learn, and it also reflects that that you are pretty active with respect to the programming. And these days, if somebody is serious in hiring developer or hiring a senior manager, if they look at the GitHub repository and they say, "Wow, this guy has created a couple of repository and has done so much," that means he is quite active and hands-on. All right. So it's quite good way to have the GitHub repository. Yeah, you can do it after we have finished the Java MapReduce part. You don't have to rush into it right away. You can do it after we finish the Java part. All right, good. Now let's take a break for 10 minutes and come back at 10:10. All right, and then we will jump into the okay break for 10 minutes. Back by 10:11 p.m. IST. So should we start? Yeah. Should we start now? Great, great. All right. Let me close these windows. Let's keep that open. All right. So now we are going to get into understanding MapReduce in Java. Then we will go through a couple of quiz questions, and afterwards we will get into the MapReduce advanced concepts, and then we'll talk about input splits, and then data locality optimizations, and what multiple reducers and combiner and partitioner, and then there will be few more advanced concepts that we want to discuss. Okay. So Vidya's question is, so I registered at GitHub. So should I submit our assignment? Yes, please. But just make sure that you send the GitHub repository as to me. The name of the repository, the URL. Okay, just the URL. Just send it to me. Good. Moving ahead. All right. We'll first discuss, do a little recap in the form of quiz questions. All right. Here is the question to all of you. Are you there? So the question is, the data generated by mapper is given to the reducer and then it is sorted and shuffled. Yes or no? Quickly. So the data generated by the mapper is given to the reducer, and after it has been given to the reducer, it is sorted or shuffled. Does it make sense? Yes or no? Suresh and Joshi? The answer is no. The output of the mapper is first shuffled and sorted, and then after shuffling and sorting, once it has found the groups, then the reducers are called on each key with all the values for that key. Correct, Josie. All right. Suresh, is that clear? All right. Now the next question. So mapper can only generate a single key value pair for an input record. True and false. Okay, let me simplify the question for you. In our word count, for each line, how many key value pairs was our map function generating for each line? One pair or many pairs? Based on that, you can answer this. So Sanjay, in case of our word count, for each line, how many pairs did we generate? For each line, in each line there were how many words? There could be hundreds of words, and we were generating hundreds of pairs, right? For each line. Yeah. Therefore, therefore, the answer is false. Correct? All right. Suresh, is this clear to you? No. All right. Good. Good. So the question needs a little more focus. Now, next question is: a mapper always have to generate at least a key value pair. Does our mapper need to always generate a key value pair? Could there be a line in our word count example for which there are no output? Could there be? Correct, correct. Thank you, Sharna. So, Sharna's answer is wrong. Good. And his reasoning is also good. That, for example, for example, you had said mail sending in bulk could be a mapper. So, not necessarily our mapper has to generate any key value. Okay? Yes. In case of empty line, there could be no key value pair, right? If there's only spaces in the line. Yes, the session is getting recorded. Vidya, do you see at the almost near the bottom of the GoToWebinar? Does it show you that the session is being recorded? And yeah, so is everybody able to hear me clearly? Because Vidya is having some intermittent audio issues. Yes, everybody is able to hear clearly. Awesome, awesome. So, is everybody okay with this, or do you want me to explain? Now, there is a good question, and let me put that. So, there's a question from Sanjay. In these cases where no key value pair is means no reducer also. Correct. But there could be a scenario where map task does not, one map task did not generate any output, while other map tasks have generated the output. Okay. By default, there is only one reducer in case of streaming job. Yes or no? Or let me ask you this way, when we ran our map streaming job to do the word count, and when we did not specify number of reducers, how many output files were created? One or many? That's correct. Yes. So it is by default it is one and can be split by the command line option called mapred.reduce. Okay, good. A quick recap of our the other things. What is the role of job tracker, A or B? A is executing MapReduce logic and B is delegating MapReduce logic to task tracker. Good, good, brilliant. Moving ahead. The map logic is executed preferably on the nodes that have required data. Yes or no? Brilliant, brilliant. So yes, this batch is actually great. I'm getting so many correct answers from the batch. Great. So this session is going good. So all right. Here, yes, that's correct. Map logic is executed preferably on the nodes that have required data. Now, next question is map logic is always executed on the nodes that have required data. Correct or wrong? Good, Lloyd. Good, Anuj. Keep going. Yeah. Good, Sandeep. Good, Lakshman. All right. So the map logic is not always executed on the nodes that have required data. Sometimes what happens is the node that contains the required data, they are busy doing something else. In those cases, it tries to find the nearest node to, to the data. All right? Correct. Thank you, Lloyd. If the data node is busy, it will choose another closest node. That is Lloyd's answer. Brilliant. Brilliant. Sarvana's question is, it would not go for replication? Yes. First, it will try to find any of the node that contains the replica block. In case that is not successful, it will try to execute it near to those nodes. You got the answer, Shravana and Suresh? All right. Yes, thank you, Tushar. That means the data will have to be transferred to the nearest node. That's correct. So, in the cases where the logic is being executed on the node where data is not there, okay, the data has to be transferred and there will be a network overhead. Okay, so there is a point from Lakshman. Okay, the point is, if the map logic depends on two different files that may have blocks in different data nodes, how Hadoop decides which one to choose. Okay, so that this is basically If map logic runs on a record, and a record is, let's say, spread across two files, this is something a part of input split and is a difficult thing to answer. Okay, so I'll explain because it will take a little bit more engaging part. So let just give me some time and I will be able to answer. Keep this question ready. And this is a very good question we are having. Shravna is having a similar question earlier. Okay. All right. So yes, data locality is a big problem in on clusters like, and yes, it is a basically very important aspect. Yes. All right. Now going to so all right. Let me explain again. So map logic is always executed on the nodes that have required data. The keyword here is always. Sometimes, sometimes map logic is executed on the nodes that do not have required data and the data has to be transferred. Okay? Data has to be transferred in order to for map logic to run. Okay? Therefore, this this statement is wrong. It doesn't always execute on the node. First, it tries to execute on the nodes which contain data, and if it is not able to find such a node which contains data and is free, then it executes it in the network. Great. All right. Where does Hadoop store the result of reducer in HDFS or local file system? Good. HDFS. Brilliant. Where does Hadoop store the intermediate data? Okay, let me. Laksh, intermediate data. The output of mapper goes to directly to HDFS, and then reducer reads from HDFS. How does it happen? All right. So it goes like this. So the data from the mapper is being collected in the memory and then being parsed into local file system, which gets shuffled and transferred to the node which is running reducer. In case in case if we try to push this intermediate data into HDFS, there will be unnecessarily replication and unnecessarily we are going to make HDFS busy because this data is use and throw. Okay. Now here is a difficult question. The whole of the HDFS block available on a node is fed to a mapper, right or wrong? Although we have not discussed it yet, even if you answer it wrong, it's completely okay. I'm just seeking what is your hypothesis. Okay. So, okay, let me put it this way. The whole of the HDFS block is always fed to a single mapper. The answer is no. The input block is passed, or I mean, we form the logical objects on top of this raw block of data, and therefore it's not absolutely, there is no one-to-one relationship between HDFS block and the mapper. Okay, so we create records on top of we create input splits on top of log, and out of input splits we create something called record. We'll talk about it now. All right, before that we have got some questions, so let me address those questions first. So here's a question. So all right, what is a commodity hardware? Commodity hardware is something with a good hardware, but not very expensive. Okay, now you can imagine that a machine with 8 or 16 GB, maybe 4 to 16 GB RAM, is a good example of commodity hardware. Okay, but if you see the expensive ones, say Blade server and all of that, they actually start with 16 GB RAM and upwards. Also, commodity hardware does not mean old hardware or does not mean having cheap components. Okay? It should be good, it should be stable, it should run perfectly fine. And again, it's a very subjective terms, and therefore there are always going to be these huge discussions whether something is a commodity hardware or not. The idea is that we are not too dependent on vertical scaling. So even if our hardware is very average size, it's completely okay. All right. Now there's a question from Lloyd, which was with respect to the previous question. Can we control where it writes? So we cannot generally control where is mapper writing. It means mapper. Okay, the mapper task. But we can control the memory size. How much size should be the memory in which mapper writes, and then the memory get purged. Okay, we can control that size. All right. Good answers. Good answers. Brilliant. All right. So good. You are all ready to move to the okay. Very good answers. Shavna is saying that it depends on the logic of the code. It may assign a mapper. Yes, it depends on the logic of the code, and therefore there could be. Therefore, the answer is no. All right. So yeah. So Sravna's point is, let me just put it this way. This is important. All right. And with respect to my commodity hardware point, continuing the discussion, the storage is subjective. Storage is subjective, very subjective. Sometimes you don't want to keep storage at all on the computer. Sometimes you want to keep it pluggable, but there is no correlation of storage with the ability of the hardware in general. But what is what is important while you are talking about storage? What we want is decent amount, something like 5400 RPMs is good enough. Okay, is good enough. The IO speed, and if you have SSD, that's also good. All right. Let me talk about Savna's question. Let me talk about Savna's question. So I think a better idea would be to go back to so there are two more questions to answer, and so does anybody else have this confusion that for sorting and shuffling you need all the mapper output data? I think this diagram will make it clear. All right. So here if you see the sorting is happening on individual node, right? There is an input split, okay, which is being passed through map function, and map function is done generating key value pairs which are being sorted on the same node, okay, which are being sorted on the same node. And once the sorting has finished or it's being done, the data is parallelly being copied to the reduce node, the node which is supposed to be the reducer. So after the sorting is finished on each node, the data is carried to the reducer node, and there the merging happens. Okay. So you can see that this data can directly go from each individual node to the reducer node without having to go to HDFS. Make sense to you now, Shravana? All right, great. All right, there were a few more questions. All right. So Lakshman, I don't have a specifications per se for commodity. It's just a very general hardware, general vague term. Okay. Now Sanjay's question is: in what cases MR should not run on node having the required data if the node is healthy? In cases when the the node is busy executing something else, because it's not only your file which a node keeps, it might be keeping the data from other files as well, and therefore it might be busy doing the processing of somebody else as well. Great. One more question. The question is from Sandeep. The question is: before we move ahead, please help me with this command. Okay. It essentially means, let's break it down. Okay. So if you see, this portion means substitute. Okay. This portion means substitute. Okay. And after the slash, let me break it down like this. This is substitute. This means substitute. And if you break it down further like this means it has to be replaced with this. And these are control structures, like saying replace in the whole file. Okay, so we are saying substitute this with this with this. Okay, and do it globally. All right. Now this means dot means any character. Dot means any character, any number of times, at least once. So you can also say things like this, and you have to put a bracket because you are trying to reference back. Okay, because you are saying $1, so I'm assuming that you are saying whatever has been captured in first bracket, get that. All right. So I would strongly recommend, if you have a problem with the regular expression, go through my regular expression session. That will make it very, very clear to you. All right. Or you just drop me this email separately. I can see a couple of mistakes in this. Okay, you have to put the brackets here. You don't require this. All right, we'll discuss it in detail. All right, and SED is a general command. When you put -r, you are basically saying that I'm trying to use regular expressions. All right, good, great. So let's get started with the Java part, and then we. All right. So MapReduce in Java. So far we did MapReduce in streaming. We did first the streaming, then we are going to Java, because lots of people are more comfortable with the streaming. And I found it that doing it in streaming is more practical way of getting it done. All right. But there are some cases where you want to alter a lot of behavior. In those cases, writing the MapReduce in Java becomes important. But most of the work can be done easily in using streaming job. All right, because in streaming also, in case of streaming also, you can write the MapReduce in Python, which is fully functional, and I learned MapReduce first in Python, then in Java. And that was a very interesting way. Otherwise, if you look at the Java way, you will actually find it more time consuming and you will never execute it. Okay, so that's a general trend. All right, so first of all, you install Eclipse, then you create a Java project. You add all the libraries which are available there. So here you will see in session number 5, there is a sample project. You can download it. And also I have mentioned how to create project. So how to import this project in your Eclipse, I have demonstrated here. Basically downloading the project, unzipping it, then there will be two folders, one for source code, other is for libraries. Import the project from the source code folder and then add all the libraries and you will have fully functional MapReduce program. Okay? All right. Now let me just start the Eclipse here. All right. So these are for Hive and others. All right. So here you can see there is something called stub driver. But before that, we'll talk about Mapper. Close it. All right. So change the JDK to 7.0 and compiler you can keep either 1.6 or 1.7 because I'm assuming that everywhere it's now JDK 1.7 on the clusters. So the idea about here, the most important part to understand is whenever you are building your code, whether for Hadoop or in general life, you should try to compile your code in a little lower version of API. So even for example, let's say you are coding an Android app, try to make your application compatible with as low version as possible because the if your program is compatible with lower version, it can run on the upper versions, but it cannot run if your program is on compiled in 1.8, it will not run in 1.7. Okay, it will not run in Java 7 if your code is compiled in Java 8. But if your code is compiled for Java 7, it will run in Java 8. Okay, so have a tendency to be as backward compatible as possible. Java 8 is okay. All right, good, brilliant. Now, the first step when we create a MapReduce project is in Java is you create a class called stub mapper. And this stub mapper should extend a base class called mapper. All right. And this mapper class, you can have a look. So is the font clearly visible to everyone? Yes. This Eclipse setup will have to be done locally on your machines. Thank you, Ganaga. All right. So let's go from top to bottom. Let's not look at the okay. Let's not look at So stub mapper extends the mapper, which is a base class, and this base class is in the MapReduce project. Also keep a note of, there will be if you get two suggestions for any of the object, say if you delete this, okay, if you delete this you will get not this one, for some of the things you will get two suggestions, so pick up the one which is in this particular package, okay, because there are still some library with respect to Hadoop 1.0, okay, so consider this package rather than the older one. All right, so here there is something like data types. Okay, you are saying my stub mapper is a mapper which accepts the key value in this format and gives out the key values in this format. This is what it means. Again, let me rephrase my sentence. So stub mapper is a kind of a generic mapper which only deals with the input keys, input data in the form of object and text, and gives out only the key values in the form of text and long writable. That's what stub mapper means. Okay, so let's go back here. Now this is like defining the data type. Okay, whatever data types you define, your function will have the same signature. For example, our map method here says it accepts the data in the form of key, which is of data type object, which is same as this one, and text, which is of this data type, and then the context. Now what is this context? Context is something, is like a big bag. It's a big bag in which you can stuff the output. Okay, this is a kind of a place where you will be writing your output. Okay, when we say that our map function yields or map function gives out key values, it's basically going to write in the context. All right, now again, so far we talked about map method getting only line as the input. Okay, here you see two things, key and the value. All right, so here what does it mean? The key is basically the the location of the line in the file, the location of the line in the file in terms of how, from which character is this line starting, and the value is basically the line. Now you can see that what we are doing is value dot to string, meaning get the string out of this text object, and then split it by space or tab any number of times, which means we are trying to convert this into into an array of words. Make sense to you? And then we are iterating over this array of words in this for loop, and then cleaning up each of the word by removing non-alphanumeric, okay, non-alphanumeric characters, by replacing non-alphanumeric characters with nothing, and then converting into lowercase, and then printing it to the output, meaning we are giving the result to the context. We are saying context.write, this is our key and this is our value. Okay, so what part is not clear in this? I know, because there is a silence in the questions window, so I'm assuming there's a lot of things which have gone above. So you want me to explain again? Alright, so the map method works on the input data, and this input data is given to map method in this format. Now, what data type will it come in format? That is something which we have defined above itself. Okay. Similarly, whatever data type which we have defined here, only that data type we can push here. All right, good question. Thank you, Lloyd. Now, what is long writable? Let me just clarify that. Okay. So the question is, what is long writable in the sense? So when Hadoop guys were trying to create Hadoop, they realized that the usual long and usual string, usual data types were not efficient enough for handling large amount of data over the cluster. Okay, because they have to be distributable, it has to transfer, they have to be serializable. For all of those reasons, they created a new library of objects. Okay, so in the base there is a long, like long, which stores a big number. For that, Hadoop guys created something called long writable. Okay, similarly for int there is something called int writable. For string, there is something called text, and so on. So they created this. So Boolean writable is there. These are sort of like boxes, as if you are giving gift to somebody. So you are wrapping that gift in the box. Similarly, long writable is basically a wrapper over long. Okay, so in this box, if you say, if you have a long writable value, if you try to get it out by saying get value, the way we are saying to string here, you will get the actual value. Okay, and this is how you can package it. So we have one here, you see one, and we are packaging one into a box called long writable. We are creating a wrapper and putting one into this. Similarly, in case of string, to convert that into text, we are using this construct. So Sarna's question is, what all data types are supported in the output? Okay, so you can have any data type. If you change here, let me try to show you. If I say that my output is going to be integer rather than long, okay, I can do this. Okay, now suddenly it will start giving us the errors. So you have to print int writable over here. All right, or if you are saying my, so basically this is saying my input key is object, input value is an object, and output key is object, and output key is text, output value is int writable, which is integer. If we say, okay, my output value is also string, then we could do, we'll have to say, we will have to say text here. Okay, we'll have to do things like this. All right, good. So yeah. So Shravana's question is, why are we using long writable instead of int writable? Because when we are dealing with millions of number, it is safer to have long than int. Okay, last line as in Lloyd, this one. All right, what we are saying is, so this context object is sort of like a chain, or you can think of it like a big pipe. All the map methods which are being executed on this particular inside a particular map tasks, all of them will have the same pointer to context object, and all of those tasks will push their data into context by saying context.write key and the value. Okay, this is a key. Okay, let me make it a little simple. Extract a local variable. Okay, and let me again extract a local variable. Now it looks little same to you. Okay, I can say output key how come I've forgotten my shortcuts. I can say out key and just copy paste it here and out value. So what we are saying here is we are creating these key, output key and output value, and we are pushing it there. All right. Yeah, that's correct. Kanaga, that's also correct, right? So do I make sense here, Kanaga? All right. So in the similar manner, we'll write something called a reducer. Now notice the reducer here, please. Here there is a key and there is a list of values. We are saying iterable. Iterable is like cursor. If you have used databases, so iterable is like a cursor which says that it's a list of values which we are getting. So to reducer, our reduce function will be called on each key and all of its values in a single shot. Okay, so here what we are doing is we are iterating over the values, getting the integer part of it, a long part of it, and adding it to the sum. Okay, and once we are done, again we are putting it to the output. The same way, so we are pushing the result of our reducer to the context. Clear to everyone? All right. Then we have, this is stub mapper, this is stub reducer. Okay. Now we define these two independent classes. Now is the time to launch. To launch it, we need to configure many things. Okay. First, what all we need to do? First, we need to tell where is our data, and second, we need to define various other things if we need. Okay. All right. I think we have unnecessarily. Where are we using it? We're not using it anywhere. Let me clean up the code a bit. This is an unnecessary code. I think during some of the class I had put it here. So let's not pay heed to it. Okay, so my stub driver, if you look at it, is basically he's having the main method. This is the entry point of our map reduce job. And this entry point has the main method. It has got the argument. So whenever we are executing from command line, if you remember our streaming job, we were passing all the arguments. All those arguments are being received in this array of strings. Okay. So all the arguments which we specify there will be received here. And we are saying if the argument length is less than 2, not equal to 2, then show this error. Okay, so this is common thing which we are basically checking the argument length. Next is we are defining something called job conf. Job conf is configuration for job execution. We are giving it a name. We are saying then for this job configuration we are creating a job, okay, which has got a name and is based on this conf. And after that, we are also telling the jar that this is our entry point. Okay. And here we are saying that mapper class is this, reducer class is this. Okay. And we are saying the output of our job is in the form of text, and value, the output value class is long writable. Okay. For our job. And output partitioner class is this, which we don't need right now. Okay. So map is giving an output in the text, and map output is long writable. This is also optional, but let it be there. Okay. And second is we are defining number of reduced tasks, how many reduced tasks we want. If we don't have this, it will by default be 1. All right. Is this clear to everyone? All right. So once we have done that, what I'm going to do is we are going to export it into a jar. We are going to say export jar, and in the downloads folder, I want to say sgmr. Okay. Now let's try to upload it. And how do you generally upload it? I will use my scp command. You can use WinSCP if you have. Okay, sgmr, and I'm saying Hadoop 17 at the rate Hadoop 3.nobigdata.com, and not this, and I'm saying copy it there. Okay. All right, let's open the console. So you see my file here, sgmr. Do you see that? Let's move that to my own folder as Giri_3. All right. And guys, don't create your folder in my folder, please. I see your folders here in my folder. No, it's not there. Yeah, you are right. It's in outside folder. Sorry. All right. So we have moved my file here, and Hadoop jar this. Now let's try if it's running or not. It's saying give the main class name. Main class name is the step driver. Okay, and there is a package which we have defined above called sg. So we'll give the fully qualified name called sg.stepdriver. Now, do you see this error? Which means it's able to run our program. It's a good news for us that it is able to run our program. Now let's specify the data, the data folder. Where is our data folder? Can anybody help me? Data was in MR, then word count, and then input. Okay, and output, let's keep it. We say output slash Java. Okay, we can put the data anywhere we want. So it has started the job. Do you see that? It started the job. We can see the status here. The word count is running. Also, there are two reduces. And why there are two reduces? Because we have defined two reduce tasks. So it has succeeded. It is successful. Let's try to see the data. Okay, so you can see that output format is same as our result. Okay, so we can say Hadoop fs minus ls. All right, you can see there are two parts here, this one and this one. You can say Hadoop fs minus cat, this one. You can do the same thing from here, the way we were doing it in the MR, in the streaming job. So we were successfully able to run our mapper and reducer in Java. Are you happy with this? Now, as you must have noticed that there was a little bit of a clumsiness in our approach, because we were first compiling, then creating jar, then uploading it, and then running it. So it's too much of thing. There are too many of steps involved. But when you are building a product or when you are writing an algorithm, this is too much of distraction and it discourages the experimentation. Right? It is when you have too many steps to do it. Therefore, it's better to write the test cases. Okay, so have a look at this class stub test. It would show you clearly the name of. So we basically in the beginning we create a dummy mapper, dummy reducer, and we run our code through this. And how do we run? We just right click on it and then say run as JUnit test. Okay, so I have purposefully put in these fail. Okay, you have to implement these test reducer and test mapper. So I have not implemented them individually. You should first test mapper individually and test reducer individually and then test your map reduce together, right? And the data input I'm pushing through here. There is something called add input provided by the dummy driver here. Okay. And it basically tests your mapper and reducer. It does not test your driver. Okay. So Lakshman's question is that can we remotely debug our MapReduce jobs while it's getting executed? Brilliant question. And those who are wondering what exactly does it mean? So if you guys have used a Java server such as Tomcat or something, all of these Java servers, they provide a way to connect to the running server and then connect to the running server and then execute it, then connect to the running server and debug it stepwise. If you have not done it so far, try doing it. It's actually quite useful. All right. So in the similar way, his question is, can we do that same thing to the MapReduce which is being run on the cluster? Honestly, I have not yet tested it, but theoretically it should be possible. Okay. Because it's a property of the Java compiler to give you hook into the debug port. Okay. So it's basically the property of the Java compiler and JVM to give you the hook into the running code. Vidya's question is, why check arguments? Because if we don't check, then user might fail to supply the the input directories. Okay, we could have hard coded the input directories, but we wanted to take the input from the command line, because output folder, if it is existing, if the output folder is already existing, we might have to modify the code and run it again. That's why we have not hard coded these variables. We are taking them from the arguments, and you can see that argument, that part I did not show you. So you can see here we are saying file input format dot add input path. So we are adding the input path into our job definition, and we are adding the output folder path in the job definition. And at the last, this is where the work is getting done. The real work is getting done here, where we are saying job dot wait for completion. Okay, job dot wait for completion, and true means what was true for? Oh, I forgot what did true do. All right. So we basically wait for the completion here. Can we also run MapReduce job directly from the Eclipse? Similar, yes, yes. This actually is running the MapReduce job. This test case is actually running a MapReduce job. We are saying MapReduce driver dot run. So it's a dummy. It's a simulated driver which is running your MapReduce job. All right. Great, great. Good. Any other question at this point? So we were able to successfully run our driver and were able to get it done. All right. Now there is one more small point here. Sometimes you have extra libraries which need to be pushed to, which need to be which need to be included. Let's take a case. Let's say your mapper function is doing a database connectivity. Okay. In those cases, or your mapper function is sending emails to people. So in those cases, you need to connect to the remote using these libraries. Therefore, you'll have to include these libraries along with your mapper job. In that case, you need to use, either you can use -use library, or you can use libjar's argument provided by Hadoop jar. Okay. So again, in case you missed the part, the way we execute our jar is Hadoop jar and my jar. After that, we give the entry point, whatever is our driver URL. whatever is our driver class name, and then we can optionally provide the list of our jars, comma separated list of our all the libraries which you want to bundle while executing the Hadoop jar. It's similar to saying that minus file option where we were shipping our script to all the nodes. Okay, so Sarna's question is, where can we get the test code? You can have a look here. You will get the test code from here. Okay, here is the sample project. All right. There is a complex example here. There are two big projects. One is there and the second one is here. All right. So Lakshman's question is, how about authentication to HDFS before running the job? So mostly if the MapReduce is running the job, MapReduce can access the HDFS directly. Okay. Because it is authorized to do so. All right. So this is an example test code. We first set up the driver, the dummy driver, and then we tell the driver that this is our mapper. Similarly, we set up the reduce driver by creating an instance of reduce driver, and then tell the reduce driver that here is my reducer. And then we create an instance of something called map reduce driver, for which we tell that this is my mapper and this is my reducer. And inside our test cases are identified by either at test annotation or by the name of the function. And then we can test all of these things. We can run our driver, we can run our various drivers, map driver, reduce driver, map reduce drivers, by providing an input data and checking for output data inside each of the test cases. All right, good. So you can create a test case like this. You can see for map reduce driver, we are adding the input data in the form of key value pairs. Similarly, we are adding the input data, more input data. And after that, we are running the driver by saying mapreduce driver.run. And then we are going through the output produced by mapreduce driver. And basically, we are checking whether it has given the correct results or not. All right. So Anand, so that was our MapReduce in Java. Now Kanaga's question is, currently is Zookeeper being used to monitor the nodes? Right now we are using Zookeeper for HBase. For HBase and for few more components we are using Zookeeper. Alright, should we start with the input splits? All right, I'll just give you couple of important points here so that we are in the mood for the next session. Here, if you remember, in case of HDFS, we basically ruthlessly cut the file, whether the boundary is in the middle of line, whether the boundary is in the middle of sentence, or the boundary is in the middle of character. In case of Arabic character, which where the each character is spreads to multiple bytes, okay, in those cases, HDFS didn't care about where is the boundary. As soon as 128 MB reached, it will cut it. Okay, so half of the word in on one node and half of the word on another node. Now imagine this: if one block contained half of the word and other block contained half of the word, when we do the word count, we will get wrong results, right? If the whole data from the block is being fed to our word count, we will get wrong result because one single word will be counted as two separate words as it is split into two. Make sense to you? So that's where the logic, the idea about input splits come into play. Let's imagine that there is a file containing 11 lines. So this example, this is another example, this is another diagram. Okay, don't get confused between the two. So this is another, there are two examples we are showing, they are mutually independent. So first diagram shows you that there are 11 lines in the file. Okay, these first 5 lines are smaller and the 10th 11th I mean this next line are bigger, in the sense that first 5 lines are almost like 128 MB. So basically this is 128 MB first block, 128 MB, 128 MB. Maybe the last block is generally smaller because not all files can be a multiple of 128 MB. Because last portion, whatever is left after cutting 128 MB sizes, whatever is left becomes the last block. Now you can see here what's happening is the line number 5 is on the boundary. You can see here the line number 5 is on the boundary, which means some part of the line number 5 is in the first block. This is first block. There are 3 blocks here. Some part of the fifth block is on the fifth line is on the first block, and some part of the fifth line is on the second block, right? Similarly, the ninth block, most of its part is in the second block, and some of its part, this part, is in the third block. But when we deal with word count, it cannot have the partial data, right? We always got the full line in a single map function. The way we had just seen, the map function was getting, one was the object key, which was the the number of bytes at which the line is starting, and then the full line. Okay, the starting point of the line and the full line, that was the input to our map function. That means the fifth line has to be read into the first node and then fed to the split. Okay, so we'll have to create input split on top of the block. So yes, Kanaga, we would have to parse and analyze the data before feeding to the mapper. We have to form something called input split, a logical representation of the data for feeding to the mapper. Okay. Also, sometimes what happens is run you are trying to run MapReduce on top of video files, and video files are binary data, and that binary data may be spread across 10 nodes, and you want to run the whole video file on a single one. Now your question would be that why didn't we store it such that, why did we cut it? The reason is, as per the requirements, based on the requirement, our input split behavior might change. Let's say we are trying to compute the signature of the big file. If we are trying to compute the MD5 signature or MD5 hash of the full file, we would require all of the data at a single place. For some other requirement, we might need one paragraph at a time. For some other requirement, we might require the 10 paragraphs in one mapper. Okay? So therefore, no single format storage will solve our problem. Okay. And hence we are leaving the parsing part or analyzing part of the data to the MapReduce process. All right. Yes. So we'll have to check for the data limits. So Tushar's question is, what is the default size of each input split? There is no default size. Okay. It is all depending upon the requirements. So I think I answered your question, Lakshmanan, without looking at your question. His question was, why can't we split during the HDFS put itself? Good question. Now, Sarnan's question is, so the number of mappers is equal to the input split? Yes. All right. All right then, that's pretty much for today, and we will go into more details. And the question, in case you have forgotten, the question which we are going to the assignment, other than coding everything into Java, the other assignment for today is this one. Okay, it is available in LMS also. Please have a look at that and try solving it. All right. All right. Thank you, Lakshman. Good night, and thank you, Michael. Bye bye. Thank you, Vidya. Thank you, Shravana. Have a good day. Bye bye. Thank you, Josie. Thank you, Lloyd. Have a great week ahead. Thank you, Suresh. Thank you, Kanaga. Bye bye. Have a good day ahead. Bye bye. Thank you, Anuj. Thank you. Thank you, Anuj. Thank you, Sanjay. Have a great week ahead. All right. Thank you, Richard. Thank you, Ravikant. Thank you, Priyabrat. Thank you, Lloyd. Thank you, Karthik. Thank you, Jairam. Have a great day, great week ahead. Bye bye.